This is Marcia Davis with the City of Spokane, Washington, and I will be speaking about permeable pavements here in Spokane, Washington, and a little bit of how we decided that permeable pavements were a good option for us. Spokane is in eastern Washington. We have on average 16 inches of rainfall a year, mostly in the spring and through the winter, with dry, hot summers. So when we evaluated both our stormwater and overall our streets are full public works from the city, we decided that we couldn't look at just stormwater or just streets or just our combined sewer, but we needed to look at those holistically. And that gave us the desire to do an integrated plan. With that, we decided every time we rebuilt a street, we were going to find a way to manage stormwater, whether it was in our combined sewer or our MS4 system. And so as we went forward, that became our basis. So the two objectives we've gone forward with this, our integrated plan, as goals as a city, are both environmental and financial. The motto we came out of with our integrated clean water plan was a cleaner river faster. And we decided we were going to remove the pollutants through every project, whether we were required to do it by a permit or not. But we also were committed to our citizens that we were not going to just raise rates without any pattern. So we are committed to only raising our rates to the consumer pricing index. So then when we started talking about permeable pavements, it was actually the management of the city brought up the fact that maybe that using permeable pavements we could manage more than one problem at a time. We could actually manage the surface problem of being able to pave a street and at the same time manage our stormwater without having to do the pipes and all the catch basins and everything else that goes with a buried system. It would give us an option also for bike lanes or to add on to our transportation network and sharing that cost with stormwater. So currently we have 5 projects that we've used permeable pavement, and we have several others that are under construction to be finished soon. Upriver Dam was actually installed in 1986. The dam is right on the river. You can kind of see in this photo here where right here is the river. So this is very close to the river, and they were looking for a way to manage the stormwater in this parking lot. And the next slide will show an update to a close-up of it. But it has worked well. It has eliminated the need for a swale, and it has been plowed. It has never been repaired, and it looks in great shape. It's working great. So we've had very great success with this. Now this does not get a lot of traffic. It's just those people that work at the dam, but it's been a perfect application for this. The next project we tried was West Broadway, which our goal was to put in pervious concrete sidewalk. That was done in July of 2010. It turned out not to be pervious. We think it was during installation there was too much water in the mix. There was too much misting that caused it to make too much of a paste, so we couldn't have infiltration. Lesson learned there. It's really important to have your installers qualified and certified. So the next project that was done about the same time, or just right after that, was Liberty Park. There was a sidewalk piece. It was actually training for the certification for this pervious concrete application. And they asked if there was someplace in the city they needed a sidewalk, and we said sure. What's interesting about this is it does infiltrate. The infiltration rate is low, but it does infiltrate. What's interesting is as you go from north to south, it improves, and so we don't know if that was because they got better as they went along, they figured out how to do it, or was it dry? Did it dry? The mix became drier through the day. Those are things that are really important for installation that we found, that you really need to manage that. And then the next one was Hazel's Creek. So we wanted to have a place that we could put these in, that we could have a place to test them and just see how they work. So Hazel's Creek are gravel trails, but we have these sections that are shown here in the circles. These are the areas that we put in porous concrete. We did that. This area here has actually maintenance vehicles, so we wanted to see how it held up. And we go out every year to test it. You can see there's gravel. The areas outside of the circle are gravels, just to see what kind of infiltration rate we would get. And we found that the infiltration rate has decreased, but it's still infiltrating well enough to manage the stormwater. We do find that we're having on the edge where that concrete is next to the gravel, there's a little bit of raveling. And our next project was the Olmsted Brother Green. We actually got a grant project to manage stormwater from one of our arterials, and the closest area that we could manage was about a half a mile away. So we actually have a force main that goes to this park. So as part of this demonstration, we wanted to do several types of pervious pavement. And this is the interpretive sign you're seeing here that's showing the different types. We have 3 different types that we're using for that, plus we have a pervious concrete parking lot. And I will show you. So that was installed in July of 2014, and it's still working great. This colored area, the dark color area here, is a product called Chlorostone, and it works very different. It actually is like a sponge. It soaks up the water and then gradually releases it. The other ones here are either permeable, that they're permeable, that the water actually goes through it, or they go through the gaps between the pavers. It's a kind of a neat demonstration. And then over here on this, we have the sidewalk. And last time we tested that sidewalk, it infiltrated so quickly we had a hard time keeping up with in the test. So it's working great. So we've had these successes. We thought, well, we're ready to try it in our street. So we had 4 projects that are either in construction or planned to go into construction. Havana, we decided to put porous asphalt bike lanes. And then next to it we have like a gravel area that if the concern is if it doesn't work, the engineering section was concerned with that they wanted a backup plan. So we said, well, this has got great infiltration in this area, so we can put a gravel swale area, an area that we can infiltrate. We do show this with trees, but we're not putting very many trees in. We decided it really wasn't going well with the project, and there are no curbs. So this is a great example of actually using porous asphalt within the right-of-way, not in a sidewalk area, and it will actually drain off of the travel lane into the porous bike lane. We're anxious to see how this works, to see if we get less freezing less ice on the bike lane because it's porous. The next one is we have at our treatment plant we had to redo the parking lot, so we decided, well, let's do some permeable pavement. You can see we've got gravel strip, grass pavers, interlocker pavers, and pervious concrete. That was construction of that was just finished up at the end of 2015, and this spring we'll be out here testing to see how well it works. This is once again a way we can share with actually a parking lot, and managing stormwater eliminated the need for swales. So the next one here is Finch Arboretum. This was a project we actually planned many years ago, about 3 years ago, and it's taken this long to get everything coordinated to build it. It's taken the parking lot and turning it into porous asphalt, and then we're managing some stormwater with an underdrain and stormwater in the area. We're also doing, WSU is doing some monitoring of temperature to compare the subsurfaces between the traditional asphalt and the porous asphalt to see if we have migration of both flow and temperature. And the city will be testing to see the infiltration rate. What was interesting is when the construction of this has just been completed, and the operations people wanted to close it off so you couldn't use it in the winter, which is counterintuitive to what we want. We've got a lot of snow and ice, and we want to see how it's going to operate in the winter, see how well it's going to hold up. And we think we're not going to have to do anything different with this parking lot than with the one next to it. So some of the more specific concerns we have in eastern Washington with permeable pavement. One is dust, because the summers are dry and we get a lot of dust. But we're planning on using our street sweepers or vacuum type, on using those to see if they clean well enough. And the other concern, and I'll show you this on our next project, is Sharp Avenue. And that's one we've been planning for a couple of years. We're starting design on that, and we'll be finishing that up in the end of 2016, early 2017. That we decided in this, we didn't want to, the sidewalks are in great shape, and we decided we didn't really want to redo the sidewalks. But we find that we get a lot better results by doing the road themselves, because it is going to manage more of our stormwater. Because we tend to have storms rather than just constant rain, although we do have that. Either we get snow, which gradually melts, or we get a more intense storm. Having the sidewalks is a small reduction, but not enough that it really makes a difference in any stormwater facilities. So in Sharp Avenue, what we're planning to do is to have 3 sections. One, we're going to use some traditional asphalt with a center swale. One area we're going to just have the bike lanes as porous, and then the next section will be completely porous. And we're also looking at doing a whole intersection in permeable pavement. We have several concrete intersections throughout the city, ones that have a lot of turning movement or bus traffic. We make concrete for the durability. And this street, Sharp Avenue, happens to be adjacent to Gonzaga University. We have a bus route here. We have a lot of pedestrians. But what we decided to do, once again, to have a level of comfort, because this is a new product, this is a new thing, what we haven't done very much here. In fact, the Finch Arboretum I was just talking about was the first porous asphalt project the city's done. So we don't have a lot of a track record, so we are going to be regrading the street to have a center depression and have a swale there. So in case there's any kind of failure on for plugging, and that's what we're imagining is plugging, or if there's a section gets a lot of raveling or other problem, we can use standard asphalt to repair it, and then it can drain to the center. And here's just kind of the details. The 3 different sections have a center trail. We're going to have trees in that center, and we'll have bump outs for pedestrians, and those are going to be standard concrete. And bike lane for that asphalt. We'll see, that's also a parking lane, which there's some concern how that's going to hold up to the turning movements of parking. We'll be doing a little bit more research to try and find asphalt design mix that can give us a little bit better for those turning movements durability. We have been collaborating with Gonzaga University, and we will be monitoring Sharp Avenue as part of a senior project. They're designing the monitoring test strip and figuring how we're going to do that. It's always kind of for Eastern Washington, sampling for stormwater is a little bit of a challenge. We don't generally get storms that are several days, and a lot of times they happen at night or weekends. So being able to have someone available to come do sampling, grab samples, and to have your equipment set up and checked, so when we do get the rain that we're ready to for it to operate is important. So they are working on actually doing a model of porous asphalt to see how exactly they can build the under drain, and we're excited to have this to move forward. So we have the monitoring system. We're going to water for both water quality, for durability, and for maintenance. Those are all the 3 things that are really important to us: being able to treat the stormwater, be able to hold up long term, and not to cause a lot of maintenance. At the same time, it'll give us a chance to, because it is right there in the campus, to have some low impact development education. And that pretty much sums up what we've been doing in Spokane. Going forward in our capital projects, we have a few that we're considering porous asphalt and pervious concrete, just because when you get into a retrofit environment, sometimes that's the only solution to manage stormwater, to take it either out of an MS4 system or out of a CSO system.